Hi, everybody, and welcome to the How We Built SharePoint Online. My name is Doron Bar-Caspi. I'm a program manager in the SharePoint Online product group. This is a level 300 session. I'm going to let Roberto introduce himself.
Hi, everyone. My name is Roberto Taboada. I'm a program manager in SharePoint Online as well. I work in the area of tenant and user provisioning. That's all I live and breathe right now. And I look forward to covering that topic in more depth with you in just a few minutes. So I wanted to go ahead and welcome you all and thank you for spending your valuable time with us. We hope to make it worth your while. I apologize in advance if my voice fails me a little bit. I think I did a little too much singing last night during the concert. Well, most of you wouldn't call it singing. All right, so let's get going with how we designed and built SharePoint Online. Here's the main objectives for the session today. Essentially, we want to cover at a high level how we design and build SharePoint Online and go behind the scenes and show you some insights into what it takes to build and manage a service of the scale of SharePoint Online, focusing deeply in the topology and how we deploy our data centers, as well as taking a look at the tenant onboarding process. We want this to be useful to you, regardless of where you are in the stages of adopting SharePoint Online. You could be using it to run your business, running a trial, evaluating the preview, or simply focusing on the on-premises experience at this point. But I wanted to do a quick show of hands. How many of you are using Office 365 today to run your business? Can I get hands? Oh, no, that's a good number. That's a good number. How about running a trial? How many of you are running a trial right now? Well, that's another good handful of people. A good percentage of the audience are already customers. How about how many of you are working with your customers, to help them onboard or try out SharePoint Online? Great. So I think we have a nice mix of scenarios represented here. Great. I also look forward to your feedback on how that experience is going. Feel free to grab us and to chat with us after the session. Okay, so quick agenda before we get going. I'll quickly start by putting SharePoint Online in context and explain how it fits into the overall Office 365 experience and offerings. Then Doron will go deep into the topology for SharePoint Online and how we manage our deployments there. Then we will turn over and talk about customer onboarding and how that process is managed and the processes that we need to put in place for that. And finally, we'll talk about upgrade and patching. And of course, we'll finish with some Q&A. And I ask that you hold your questions till the end. We have a pretty packed deck, and I want to make sure we cover all the topics. But again, we're happy to chat after the session, over a beer, what have you. Some related presentations. I can't list them all, but these are some that you should check out. Especially, there's one by Ben Canning at 5 p.m. today. It's essentially a complementary presentation to this one, and he will talk about how we run the service. Oh, there's Ben in the back. Ben, say hi. He's going to cover how we run the service with zero downtime, zero data loss in a secure fashion. Okay, so let's start with an overview of where SharePoint Online fits in the context of Office 365. And then we'll go and dive deeper into SharePoint Online. So first of all, Office 365 targets a very wide range of segments. We cover everything from consumers to small businesses, mid-size, enterprise, government offerings, educational institutions. And SharePoint Online plays a role in most of those experiences, pretty much everything from small business on down. And while we aim to have a certain core of functionality that's common to all of these experiences, we also try, where possible, each of the different scenarios brings with it its own set of challenges and its own custom experiences that we want to tailor to, and that'll be evident in some of the when we talk about things like tenant provisioning, for example. So, what are different layers of Office 365? So, at a high level, the entry point, the gateway into Office 365 is the sign-up experience and the common UX portals that you use to manage your tenancy. All that, when you get onboarded, you're simply signing up as an Office 365 customer. You're not a SharePoint customer, an Exchange customer. You're an Office 365 customer, first and foremost. We also have a layer of shared infrastructure and platform, the types of things that we wouldn't want to duplicate for each of the services. Things like commerce and billing, identity authentication, and internet DNS registration. If I were to use commerce and billing as an example, SharePoint Online is not aware, if you're one of our customers, we're not aware of how much you paid for it, if you're in trial, if you are paid, if you are beta. We simply know that a tenant is a tenant, it's active, it's functional. That we leave that layer to the shared infrastructure to manage all of that, to manage the billing, the payments. And at the lower level, there's the actual services. These are the features that ultimately folks like yourself sign up for, and that includes SharePoint, Exchange, Link, the Office web apps, and other offerings as we expand. Another bit of context and a different way to sort of pivot it is in terms of service plans. I mean, service plans are what ultimately define the capabilities that a user or a tenant are entitled to. And when you sign up for Office 365, you buy into or you sign up for an Office 365 plan under certain terms and conditions. And those terms could be a trial, that's a 30-day trial. You may be paying month to month. You may be doing volume licensing. But each of those plans that you opt into, it has individual plans for each service. So when you take a look at, for example, the Office 365 for Enterprises offering, it has a SharePoint component, Exchange component, Link component. The SharePoint plan for Enterprise, in turn, entitles you as a customer to a certain set of capabilities, to be able to create custom site collections, to have a SharePoint tenant admin experience, to turn on a certain number of enterprise-level features. So the services themselves need to react, need to translate those capabilities expressed by the service plan into actual features and experiences. And within each one, within each service, including SharePoint Online, there's multiple different experiences that correspond to each of the different service plans. And we'll cover that in a little bit more detail once we get to the provisioning bit. Finally, at a top level, before we dive into the details, what are the, once we start looking at SharePoint Online specifically in more detail, what are the different pieces of it? Well, first and foremost, we have the SharePoint bits. So these are the actual bits that are the same that we ship on premises. We build the features in a way that they're cloud ready, so that they can be used both on premises and in the cloud in SharePoint Online. They're the same bits in both places. The second part, and it's a critical component of SharePoint Online, and what we're going to talk about today largely, is the service fabric. It's a set of components that are required for us to run the service. And they include multiple things, some of which are listed there. Deploying our topology in different environments, identity and sign-in, provisioning of tenants, tenant admin, upgrade, high availability, disaster recovery, monitoring, you name it. We can't possibly cover all of them, so we're going to zero in on a few specific ones that actually cause a lot of the day-to-day operational churn for the service. As I said before, the topology, which is the overall topology for the service and how we deploy it. Provisioning, which is how we onboard users, and upgrade, how we actually keep those bits up to date. And as I said earlier, Ben Canning in his presentation later on will cover some other aspects such as monitoring, security, and other aspects of it.
Maybe you should aim it here. Aim it here.
Oh, thank you. Finally, I'll leave you with this before I turn it over to Doron. This is the SharePoint Online ethos, and this represents our promise to our customers, and it's something that permeates everything we do, and I think you'll see it throughout the presentation. Our service is big, operates at a massive scale, but it needs to be easy for us to maintain and manage, as well as for our customers. It needs to be affordable, and above everything else, always available. It needs to be super, super reliable. And With that, I'm going to turn it over to Doron to talk about the topology and what's under the hood of SharePoint Online.
Thank you, Roberto. So a few notes before I dive in. The SharePoint Online topology and automation at scale that I'm going to show you today was built by a group of people that is a mix of people with on-prem enterprise experience and people who came with large-scale cloud data center deployment experience. And together we've made what I'm going to show you here today. Now, SharePoint Online is a living, breathing, evolving service. If you were fortunate or unfortunate to listen to Roberto and I giving this talk a year ago, it seemed a bit different because we've changed since then. And we keep changing. We keep learning from the service, we keep learning from on-prem, and we're feeding that information and that learnings back into improving the service and improving our on-prem offering. So if you come and listen to us again next year and the next 2 years, et cetera, you will see that these slides keep changing because we keep incorporating that feedback in and improving. So this is how it looks as of today. If I'm going to start from top bottom and going deeper into what comprises SharePoint Online today, first of all, we have all the physical assets. We have our data centers, we have servers, we have network that combines it. And when we designed SharePoint Online, we had to take into consideration all of that. We didn't just like install the disk on some drive and run setup.exe for the cloud. We had to be aware of the data centers and locations and all of that. Second of all, we heavily rely on Hyper-Vs. That's one level deep below the physical layer. We run everything on Hyper-V, and we use units of scales that are called networks. And I'll explain in a minute what are networks. Then we had to design the next and last layer of what actually is running and where is it running and what is it interacting with. And that's what I'm going to explain here today. Remember that everything we built, everything on almost every layer, not almost every layer, we've built it in a fault-tolerant way. There are always doubles. There's always more than one, either a service or a server or a machine or a rack or even a cable. There's always going to be two of those. And Ben will, again, cover that later. We took a big dependency on Hyper-V, and we're very, very glad we've done that. First of all, it made our deployments very, very simple because all we have to ship around are VHDs. VHDs are a snapshot of a disk that isn't connected to any machine until you put it on a Windows server. You ask Windows to give you a new Hyper-V and use that VHD as a baseline. Think of our VHD deployment mechanism as a stem cell. When the build lab gives it to us, it doesn't have any identity. It doesn't know what it's going to do. And then we deploy it to many, many places. And we give each VHD a different role. We basically give those stem cells some meaning in life. It also gives us a lot of confidence that when we ship a VHD and it will sign off by the build lab and the testers, we know we have a good baseline. And if we have a problem in one Hyper-V, in one VM or two, we know we can always kill them, stand up new ones using the baseline, and we should be good to go. We have seen no or negligible performance impact from virtualization. I actually, earlier today, thought I should even remove the word negligible. It's not a concern to us at all. We gain a lot from a manageability perspective, a deployment perspective, placement perspective. Hyper gives us a lot, and we're very happy we took that dependency, and we're going to, for the foreseeable future, keep running like that. So I removed a lot of the animation I used to have in this slide, and I'm going to just explain it. If you happen to look at an older version, it had some animations. This is how a data center looks like. We have units of scale, again, we call networks. A network is an arbitrary unit, which basically says that SharePoint stamps that live within a network share some resources. What I call a SharePoint stamp, most customers would call a SharePoint farm. The reason I call it a stamp is because it is comprised of 4 farms. You can see 2 stamps here. One is a federated services farm, the other one is a content, a SQL farm, and a directory farm, or Active Directory farm. I actually have 2 stamps here, one in one shared network. Why are they in the same network? Because they share resources. What resources do they share? They share a load balancer, the hardware load balancer on the right, and they share some services or physical components like Active Directory sync that Roberto will talk about later, monitoring and diagnostic capabilities, logging capabilities, the provisioning are the tools and capabilities that create tenants or users or delete them, and Roberto again will cover that. Backup share, SMTP servers, and a bunch of others. Those are the shared resources for the SharePoint stamp or other SharePoint stamp that live in the same network. Excuse me. The content farm itself has web front-end roles. I think we roughly have about 10 of those in each farm. We have central admin boxes, which is web front-end that runs central admin services. It is not open to the load balancer. It can only accept incoming traffic, and I'll later explain why we use what we do with the central admin boxes. We have a crawl web front-end, actually a couple of those, I think. Everything is always multiple of those. The crawl web front-end is the one that receives the crawl traffic from search. Sandbox, app servers, and timer jobs are all dedicated machines that do certain work. The federated services farm runs things like UPA, user profile, the metadata service, runs search, and later I'll get into why we decoupled the two farms. Now, just to mention, again, we are constantly changing this topology based on learnings and the service, and in the future we might show you other topologies. This is exactly how we work right now. SQL farm, a few dozen SQL servers that serve both content and federated services. And we have the directory farm, which is what I call local Active Directory. It's the users that are hosted in that stamp are managed in that Active Directory. And those 4 farms will comprise of a stamp. 2 of those together in a network. In this example, we have sometimes more than 2, sometimes just 1. We will have something in the order of an identical setup in a different data center. Okay? In every region, we will have at least 2 data centers that have the same number and the same capability and the same capacity in case that partner data center is lost. And again, it will be covered later. And we have a set of components, what Roberto called the service fabric, which live outside the SharePoint stamps or the networks as it is. First we have Grid Manager. Grid Manager is the brain of SharePoint Online. It's the orchestration and automation service, and I'm going to cover it in the next slides. We have the global directory that manages all of the customers, from which the local Active Directories and against it sync. From it derives the data. Tenant admin is the component in its SharePoint that basically, from which the user tells us what he wants to do. He wants to add a site, remove a site, add the users, etc. It's an external data source for us. The commerce backend is the component that handles registration and payments. In SharePoint, I never store your credit card. I don't even have a page to take your payment methods. It's all managed by the suite operations outside of SharePoint Online. And we literally just get notifications, what customer bought what, etc., and what should we do with it. We obviously have DNS, multiple DNS services that we rely on for various capabilities. We have what is called here Org ID. Org ID is an external authentication service based on what you guys know as Live ID or Microsoft account. So a sister service of that is used to authenticate Office 365, mostly commercial customers. Incident management systems. We have Azure and Windows SQL as a big component that we work on top of, like Access and Workflow and a bunch of other marketplace-related apps work against Windows Azure or SQL Azure, and SharePoint Online interacts with that all the time. We provision databases in SQL Azure, we decommission them, we connect to them, we reconnect to them. We do that in the back and behind the scene all the time in order to allow for richer solutions to be built. And last but not least, we have CDN capabilities. So SharePoint Online today knows how to push content, static content, out to CDNs. And when a user browses to a page in SharePoint Online, He may most likely get a lot of his static content, JavaScripts, images, and others from a local CDN while downloading the dynamic content directly from us, from our data center. So in a nutshell, this is how a data center for SharePoint Online looks like and the satellite services that serve it. Oh, by the way, just one question that I answer I know I'm going to get asked. One stamp serves about, Zach, 100,000 end users? About 100,000, so that's roughly the orders of magnitude that you can think about. Each stamp will hold 100,000 users. If we have multiple stamps in a network, that means multiple hundreds of thousands of users per network. So let me talk about Grid Manager for a second. Like I said earlier, Grid Manager is the brain for all the automation that we do at scale, cloud scale in SharePoint Online. We have one instance of it. It's comprised of two layers. First of all, there's the layer of the stateless web front ends or grid front ends or whatever you want to call them. It's a set of binaries, a set of web APIs and web services, and it handles all the business logic and automation for SharePoint Online. And then we have the back end that has SQL servers, no business logic whatsoever, just the state of objects, machines, servers, tenants, sites, URLs, IP addresses, everything. So think of a back end with the information and a front end with the business logic and the actual doing of the automation. Grid Manager manipulates remotely physical servers, Hyper-Vs, SharePoint services, everything using remote PowerShells. We refer to scripts that run on the Grid Manager side as jobs, and scripts that run on the remote machines as just scripts. So there's jobs and there's scripts. Grid Manager will also get requests from our human operators. We don't have many of them, as I said. I actually haven't said earlier, but Grid Manager is the tool that allows us to run a SharePoint Online with the very, very limited number of humans that actually ask for what to be done. But in some occasions, a human will actually go to Grid Manager console and say, do this, and Grid Manager will just basically do it. Grid Manager talks mostly with other servers in the greater SharePoint Online area. So it will talk to machines, ask them to do things, and I'll show you examples. And in return, they will constantly tell Grid Manager states and report back and make requests for other resources to be moved or added or whatever. This is a PowerShell screenshot that I've taken to show you how Grid Manager looks like from an object perspective. Grid Manager is a self-aware object. We actually have a step called Grid Manager Self-Awareness when we install it. This screenshot is Grid Manager on a dev box. We have capabilities to run all of SharePoint Online, Service Fabric, and Grid Manager on dev boxes to allow our developers to debug and test code on their dev box. So you can see some of the properties that we have here. The second property says that the data center is a dev box. And most of the properties that normally, if I would take in the production screenshot, will have values are basically blank here. But Grid Manager is itself a component in SharePoint Online, but it's just self-aware, and it builds itself. So what are the operating principles of the cloud operating system? First of all, it knows the state of all the objects it manages. Every tenant, every site, every URL, every IP address, every machine, every server, every service that runs everywhere, Grid Manager knows what the current state of that service, where it is, what to talk to it, how to talk to it, and how to manipulate that object. All code, all jobs, and all scripts that are deposited in Grid Manager that basically are ways to manipulate all those objects are written in what we call idempotency principle. If you retry that code against that object multiple times, nothing bad will happen. You will always get to the same end goal. The reason we're doing that is because we operate globally, many, many data centers. Grid Manager has to talk across the world all the time. And in many cases, outside our control, we lose network connectivity or there's some glitches. And Grid Manager has to be able to retry and sometimes run asynchronous operations many times and make sure that an operation is concluded successfully. And all code is written in a way that if Grid Manager has any doubt if a certain end goal wasn't delivered, it will just retry, very simply. Grid Manager has about 200 atomic operations, and I'll show you a few of those later, and a couple of hundred remote scripts. Each object, machine, Hyper-V, it's an object. A physical machine is an object. A site is an object. A tenant is an object. Excuse me. Has two states that Grid Manager manages: the current state and the desired state. Think of a server. Right now, it's in active state. You want to decommission the server. You basically ask Grid Manager, please put it into a deleted state. You have a tenant that is in non-existing state. You want to put it in an active state. You have a site. Again, you guys understood the examples. Basically, Grid Manager, all it knows are what the current state and the end goal of an object is. If you want to build a farm, build machines, build VMs, excuse me, add sites, you basically tell Grid Manager what objects and what states you want them to be at. And Grid Manager has the state machines and all the jobs and all the scripts to take every object and all its dependencies from point A to point B. Like if you want to add a farm, you basically need to add many VMs and many, many services. Those are all dependencies of moving a farm from non-existing to existing state. I took an example. One of our jobs is to deploy a VM. It's a very atomic operation. We're doing it all the time, maybe hundreds of times a day. I just want to show you. Think of deploy VM as what an on-prem administrator would do if he wants to add another server to his farm. Excuse me, my throat. I'll just drink something. So your administrator wants to add another VM to the farm. You would first open some console. It's equivalent to our run step number 1. A step in Grid Manager, in the Grid Manager job, is defined by a continuous piece of code that Grid Manager would execute against a remote machine. And in between steps, the job can be put in a suspended state, and that thread is being used to run other jobs and other steps. And I'll show you exactly in a minute what it means. So when Grid Manager wants to deploy another Hyper-V in some remote farm, in some remote data center, step number 1 would copy the VHD to the remote physical server. Would boot up, would join the machine to the domain. It's step number 2, add administrator rights, introduce that to a few more security groups that we have. In between step number 1 and step number 2, an unknown period of time might pass. Grid Manager knows how to retry in case a machine dies in the middle of a step. We copied the VHD, and halfway through the physical server died. No human has to intervene. Grid Manager will detect that the machine just died, and it will just pick a new physical machine and restart step number 1 against a different physical machine. Step number 2, if step number 1 was successful, apply security settings. Step number 3, which is the most important one because we're all here, execute some configuration script that turns this stem cell VHD into a meaningful SharePoint role server. So it's configure some role, a web front end, and central admin box, a SQL box, right? Grid Manager, when it deploys a farm, knows how many web front ends, how many central admins, how many SQL boxes, etc. it needs. So it will deploy as much as it needs, how many VMs it needs, and each one of them will just run a different step number 3. So far, so good? Step number 4, install SCOM agents. Step number 5, some miscellaneous configurations that I deleted from here. Step number 6, very important. Change the Hyper-V settings to have external connectivity through the firewalls, through the routers. Step number 7, add additional drivers if it's a SQL Server box. If it's not a SQL Server box, Grid Manager will skip that step. Step number 8, run verification tests. This is a very important step. Grid Manager will run a set of remote tests against that machine. If it's a SQL box, if it's a web front end, there are certain types of tests that needs to be run against each type of role. If the VM fails this step, Grid Manager will kill that VM Go back to step number 1, pick a different physical server, and start from scratch. Because when somebody asked Grid Manager for a VM, it expects a VM. It doesn't expect a set of error messages and retry windows to pop up. So Grid Manager will run it again until he either runs out of physical servers or until he provides us with a VM. Step number 9, change management bookkeeping. Since step number 8 was successful and the VM is, for all intents and purposes, functional, we can now go and update some places in the service that say we've installed this, we've put this, now it's operational. Step number 10 will add more updates. Step number 11 will test the connectivity. Step number 12 will launch a parallel asynchronous job to install security patches and other updates. In parallel to this job, he can spin a second job to install additional updates. Step number 13 will wait until step number 12 ended. I won't go into why this is not a sequential step, but we've selected to do a parallel job. I won't get into that. Step 14, the VM is up, running. It can talk to the world. It's configured. We've already installed all the patches we need to. We have to connect it in step 14 to the global logging system. All of SharePoint Online has one massive global logging system that all components write into. And only when the machine is baselined and healthy, we connect that VM into that logging system. And step number 15 is, once the VM is healthy, introduce it to the load balancer and start using it. So this is all of these 15 steps, what we call deploy VM script, is one atomic operation that Grid Manager, one of 200 that Grid Manager has, and they serve as his tools, his main tools to orchestrate the automation that we need at cloud scale. So let me zoom out a little bit. And how does this look like? This is a diagram in time from left to right. And again, thanks Dan and everybody who helped me get that in the last minute, because I had some graphic problems. Let's look at it from left to right, from hour 0 onwards, from top to bottom. Basically shows us what jobs Grid Manager is firing and executing against remote machines in order to arrive to a state where we have a SharePoint stamp up and running. The first 3 jobs, 43, 47, and 50, collect statistics throughout the subsequent jobs. The first thing Grid Manager would do in order to give us a SharePoint stamp is to deploy a SQL farm and to deploy the Active Directory farm, the local AD farm. You know that if you install a local SharePoint on premises, you will first make sure you have Active Directory and you have a SQL. This is exactly the same. So for SQL here, this is a test environment. This is not this production scale. I ran this on a test environment, so it's less. The number of VMs here is less than the actual production one, but it shows the principles of what I'm trying to say. We run 3 deploy VM jobs. It's 78, 79, and 80. So right over here, those ones. And every time you see a continuous color, that means that that step ran continuously. And remember, step number 1 is copy VHDs and stand up the machine. Every time there's a white gap, it means that there's some sleep time in between those steps. So for all this, and for you guys on the other side, it's right there, we install 3 SQL servers. And you already remember the 15 steps it takes to stand up a VM, configure SQLs. Job number 81, activate farm, ties it all together. And at the end, he finishes right after the last deploy VM job finishes. It's the 4th job here. That's it. When this job finishes, we have an active running SQL farm ready to be used by this stamp. Same goes for jobs 84 and 85. Deploy 2 VMs. They basically have Active Directories with our additional code on top of it, and our activate farm, which ties it all together. And at the end of these 2 big chunks of jobs, we have a SQL farm and we have an Active Directory farm. The last one, the last VM we add here adds another VM that ties the Active Directory farms to the external global Active Directory farms, and we need to put that in place before we move forward. configures federated services farm. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 deploy VMs. Different roles. You can see each of them ran for a different period of time, except for step number 1 that is almost identical to all of them, where we copy the VHDs and we remote configure that window. Well, I'm sorry, Windows servers. All these VMs take different amounts of time to be configured, and the steps run on different amounts of time. That's because it's different SharePoint roles, and we have to configure different things and different configuration in each of them. It takes, and maybe the machine has to reboot, maybe IIS has to restart. I don't know off the top of my head, but you can see that they all run asynchronously. The thing that tied them all together is that last job at the end, activate farm for the federated services farm. Now we're at 2 hours in. It's a little bit slow because it is a test environment. So 2 hours in, we start configuring the content farm. Again, we have a few deploy VMs. It's from 296 to 302. All these at the top. Those are all deploy VM for the content farm. The last one is activate farm for the content farm. And it runs way after the last deploy VM ended. The reason is it has to tie the content farm and the federated services farm together. Introduce the services, introduce the proxies, put all the certificates, make sure that the two farms can now talk together. All these jobs, those little jobs that are run here, remember the asynchronous patch VM jobs that the deploy VM job spun up? All these run in parallel and install the updates that are very recent. They didn't made it into the VHD because the VHD might be days or weeks old, and we might have security patches that just came out a few hours ago. And since we have a commitment that those machines will always be patched and always be up to date, those VMs pick up the latest and make sure those VMs are patched. The last couple of jobs that run 4 or 5 hours after we started are just adding config DBs. I'm sorry, content DBs. It's configure DB job, but they add content databases. So basically, they start putting in some bootstrap storage so the farm can be used. So in a nutshell, this is one set of jobs that Grid Manager will run remotely against a few dozen machines to stand up one STAM. In parallel, it runs many other jobs. I think a couple of 100,000 jobs a day that have to do with standing up farms, with patching them, with taking them down, with deploying sites, with deploying tenants, moving them around. Question? Yes?
What was the total duration for one STAM?
Right here in this test environment is 6 hours. Yeah, you can see on the upper right-hand side, we've reached 6 hours in that test environment. And I think this one ended successfully. So this test environment stood up, and whatever test we've done against it started right about after 6 hours. Well, we run this sort of tests to test Grid Manager itself, to test the jobs themselves. These are less SharePoint-specific test environments. There are more Service Fabric, Grid Manager, deployment upgrade types of test environments. So just a couple of screenshots to show you that it's not just PowerPoint. When I asked Grid Manager to show me a zone, this is what properties of a zone are. Zone, again, is a unit of scale above a network where we where we manage our hardware, physical servers, load balancers, and VLANs and IP addresses. They're managed at the zone level. You can see that a zone has an ID. It knows what data center it is. It's at a state active. Remember I told you every object in Grid Manager has a state. If it's active, that means it's healthy. All operations that are allowed to be done on an object can be done. There are states like probation or deleted or in deletion or stuff like that where an object is only capable of doing some of the operation that it normally does. But an active means the object is serving all traffic or whatever it's supposed to do. So basically a zone is a logical unit. It doesn't actually exist, but we store objects in it. But then I asked Grid Manager, please show me all the networks that you have. And you can see that a network has a zone ID, has a name. It belongs to geography, US, EMEA, excuse me, APAC. And a network has a time zone. One of the properties of a network is what time zone are you in? a lot of our heavy-duty maintenance tasks will be done off-peak hours for that geography. It doesn't mean that we take down the network. It just means that things like backup of the content database or running a big indexing for search will be done during that off-peak hours. Now let's look into network 11. Show me all the farms in network 11. You can see there's a farm ID for all the farms in network 11. There are content farms and network farms and SQL farms. I can see what build they're running, and I can see what's their recovery farm ID. Recovery farm ID is their parent farm on the disaster recovery data center. Let's look into farm 1368. Show me all the VMs that run in farm 1638. And you can see the VM has a VM ID. It sits on some physical machine. That's the P machine ID. It has a role. Some of them are web front ends. Some of them are central admin. Again, these have a version or binaries that run on them, what version that is. And the VM image ID at the right, when we took the VHD stem cell, that baseline build, to know what role to apply on top of that, that's the VM image ID. You can see that all the web front ends got 5729, and all the central admin got 5724. So we set and we wrote that XML that says what to apply to a baseline VHD in order to make it a front end. It actually has a code, and under the hood, that's how Grid Manager does that. That's a little bit under the hood, and I'll give it back to Roberto. Thank you.
Thanks, Doron. So now we're going to talk about tenant onboarding, basically, which is one of our biggest sort of day-to-day activities, just actually signing up our customers to use the service. So not only is the provisioning system the front door for new tenants to walk into SharePoint Online, the provisioning system also makes sure that any change that you make as an Office 365 tenant that has SharePoint implications, that those changes actually get made on the SharePoint side, essentially. So if you add new users and you assign them a license, it also makes sure that those users are able to access SharePoint in turn. So it's more than just doing the initial provisioning, even though we're going to talk a lot about that piece. And now I'm pointing this the right way. Great. OK, so what are the different layers? I'm going to start with a quick overview of the end-to-end story of provisioning. And some of this will sound familiar from the earlier slide. And then we're going to dive into 3 aspects of provisioning. One is choosing where to provision a tenant. How do we place them in a specific network or farm? Number 2, how do we structure the provisioning, the work that we have to do for provisioning a new tenant? What are the different pieces, and how does the process work? And the last part, which is actually a new scenario we didn't cover last time, and it's more relevant now. So SharePoint 2013, the experience is coming to SharePoint Online, and as part of that, we are going to eventually have to move tenants from the 2010 experience to the 2013 experience, and provisioning plays a key role in affecting that transition. So we'll talk a little bit about that as well. But anyway, back to the sort of how it works end to end. So clearly, the first step is you sign up for an Office 365 offer or service plan. You select the services that you want, and at that point, you become an Office 365 tenant. All your properties are stored in the Office 365 directory. That's the ultimate source of truth for the service. There's an admin experience, an admin layer at the Office 365 level, which you can use to, again, start onboarding your users, manage the licenses. You can change the services that you opt into. You may make changes to it. Once that's done, assuming that you signed up for a plan that contained SharePoint Online, we are notified. SharePoint Online is notified, and we're told, hey, we have a new tenant. Let's go ahead and place this tenant. So now we route that tenant to a specific network in a specific data center and in a specific farm, and we'll talk about how that works in a little bit. The key properties that we need to provision that tenant are synced down from the from the Office 365 shared directory into the SharePoint directory, including users and some licensing information. And from here on out, the provisioning service sort of takes over and makes the necessary changes happen. In the case of new tenant provisioning, It's going to talk to the SharePoint Tenant Manager, which is really, it's really a portion, it's really a part of Grid Manager. So Grid Manager is sort of the brain of the entire operation. Think of the Tenant Manager as sort of the customer-facing portion of that brain. So essentially, provisioning will talk to Grid Manager via some web service APIs and schedule some work that needs to be done to set up this new tenant that's coming in. Grid Manager will go ahead and queue up the jobs that need to happen to create or provision the necessary site collections, users, add users to security groups, and other activities. And then all that work will get done at the SharePoint layer. So essentially, those jobs will eventually translate into PowerShell scripts that actually do the actual work of creating the site collection or assigning existing site collections to the tenants. And we'll also dive into some of the details of how that provisioning workflow is structured in a little bit. We do this clearly on a massive scale every day. We're talking at least 30K or so trial tenants new that sign up every week. This includes a variety of different offers. This is a small business, enterprise, educational institutions. It also is multiple versions. We support 2013 preview customers as well as 2010 customers, and increasingly the balance is going to shift from the 2010 experience to the 2013 experience once we hit the general availability milestone. We handle tenant lifecycle changes daily, thousands of those, and so every tenant, as they onboard users, that represents a change that provision needs to take into account. And as much as we don't like to think about it, there's also deprovisioning. Many trials will end up in folks abandoning that trial, and that tenant will eventually need to go through a life cycle and get deprovisioned and cleaned out, making room for new trials tenants to get onboarded. And of course, as Doron pointed out earlier, the Grid Manager has to coordinate across all of these different types of activities, deployment activities, upgrade. Tenant onboarding is part of that, so it's part of the overall equation that goes into the keeping the system busy day in and day out. This way, yes. So now it's not even working. Oh, there. Okay, so the last thing I'll say before we dive into the first step, the routing step, is we set up different tenant types. I want just to quickly illustrate that with a couple of screenshots. This is what the team collaboration site looks like for an enterprise tenant. You see, very focused on collaboration, adding lists, starting the sharing process. Contrast that with this one, which is this is a developer customer. So this is a developer site. If I sign up for a developer site, this is geared towards helping me build apps and manage apps and publish apps for SharePoint in the SharePoint marketplace. So it's a tendency for one developer user to actually go through that life cycle of building and managing applications. There's a lot of stuff that's shared across both of these types of customers, these types of tenancies, but there's also differentiation that provisioning needs to take into account. And it's part of what our system does, like I said, every day on a fairly massive scale. So let's talk about routing tenants. Let's take a step back and say, how does that work? That aspect is really interesting. So there's several factors that go into deciding where we end up placing a tenant. First, there's available capacity. We can't place a tenant in a farm that's full or it's reaching its limit in terms of a number of users. And of course, the capacity picture is changing day by day, right? If you imagine that we close a farm to new tenants because it's nearly full, a couple months later, there may be lots of room in that farm as certain trial tenants get deprovisioned because they did not convert. Operational activity is another factor. What's going on? What upgrades or deployments are going on in a specific network? Geographical location. We want to put you in a data center close to where you are. That only makes sense. The tenant version. While we've run the betas and programs like the preview, we designate, since we don't expect a ton of traffic, we designate a certain number of networks to run that beta or that preview program out of. Even though it's a transitory state, eventually our entire system will support the 2013 experience. Ultimately, a service plan. We also have that capability to look at the service plan that you sign up for and put you in a specific location. We try to avoid that. We try to keep our logic fairly simple, but there are scenarios where it's there's a compelling need. For example, for government customers, they go into specific networks that have data isolation, and we actually place all government tenants in those specific networks, so we are aware that you signed up for that specific plan. We look at that plan and we place you in that specific network, in that specific farm. And of course, within a network, there can be multiple farms. Those farms can then be opened and closed as needed to manage capacity. As I said, if one of the farms is getting particularly full, it can be closed and then reopened later. And potentially, as a result of a farm closure, we may need to route fewer tenants into that particular network because its overall capacity is now diminished. And let me illustrate this with a visual here of this is a snapshot of our network map. I've sort of changed the data around. I simplified it to make it a little bit easier to read, but the fundamentals of the schema are there. And the way to interpret it, for example, if we zoom in the SA portion for South America, you can see that tenants that are in that region of South America are being routed effectively to 3 distinct networks, noted here by 1, 2, and 3 in this example. The numbers next to those networks, 4, 8, and 8, represent the relative proportions of tenants, of numbers of tenants that are routed to each of them. So, for example, out of 20 tenants coming from the South America region, 4 would go to network 1, and 8 would go to networks 2 and 3, respectively. And those weights, like I said, can be adjusted at any time. We also provide, we have different layers of routing. We support overrides of that default functionality. For example, if we wanted to route a specific tenants for a specific country, in this case Brazil, to yet another network, we could do that. So the country BR here essentially is saying, hey, route tenants that are from Brazil within the South America region into network 4. So they would all end up in network 4. So we have that, that capacity. We can also do it, like I say, by service plan. I don't have an example of that, but we can also say, hey, an exception to this rule is that, let's be more specific. Tenants with a specific service plan go somewhere else.
So is this based on country of origin for the organization?
Correct.
So how do you handle
Repeat the question.
organization that has users coming from all over?
So the question, just to repeat the question was, is this the country of origin for the customer? And the answer is yes. And the follow-up question is, how do we handle organizations, if I'm understanding correctly, that have users in multiple locations? I mean, right now, when you sign up for Office 365, you choose one primary location, and that is the determining factor. Essentially, we currently don't support saying, hey, we are spread out across these 10 locations, provision me in 10 places. But it's a scenario, and there's a host of scenarios that that
if
make
you
us
saw
consider that.
Jeff Deeper's keynote demo, it was done against the European data center, and you saw the performance. We live in a world where a couple of more milliseconds are not a big issue anymore. With the additional CDN capabilities that we have, browse caching all across your stack from your client to the Windows through the network, it's not a big deal as it used to be.
Here's another example, actually, that I wanted to show to illustrate the version awareness. So version is another thing that we can actually use as a routing factor. So here we have essentially tenants that are tagged with version 15, meaning that they should get the 2013 experience. And we are routing, say, those tenants right now in this example to only 3 locations, networks 11, 12, and 13, because we're only onboarding preview tenants for the 2013 experience. Eventually, this portion of the map will expand, to cover our entire capacity. All of our networks will be represented in this portion of the map, because after general availability, shortly thereafter, all tenants that come in, by default, will be tagged with the 15 experience, meaning that they'll get the 2013 experience, right? So it's interesting that there's this interesting transition phase. There's always a version that's being phased out and one that's being phased in, and the map reflects that. So right now we can afford to say, hey, we only have 3 networks supporting this experience, but eventually it'll expand. Okay, so let's dive into the provisioning section. So I'm going to cover sync just very briefly. So syncing, essentially, I'm using as a segue into the provisioning action. So syncing means once I've been placed into a network and in a particular farm, we will start syncing down changes from the Office 365 directory into the SharePoint directory. And these are all the changes, all the information that we need to take appropriate action. From here, our provisioning service will take over and we'll make sure that that tenant is properly set up. And that's what we're going to cover next. So the provisioning service, what is it? Well, it's a Windows service in charge of obviously setting up a tenant. It sets up the site collections for the tenant, and this is done via jobs that run PowerShell scripts on SharePoint to effect the change. All the operations for the provisioning system, as Doron mentioned in the set of operating principles, they're idempotent, meaning that they're always trying to get you to the desired state, but they can be run multiple times. And in fact, we take advantage of that idempotency of provisioning in order to fix things. If a tenant, for whatever reason, wasn't provisioned right, we can rerun provisioning on it and be assured that it's not going to mess anything up. It'll try to get them to the desired state. It is able to handle different topologies for different tenancy types. We'll talk a little bit about that. And it also does additional tasks like setting up DNS entries and domains, and also creating users and groups. So when users come in, they get added to security groups. And via the addition of users to security groups by license type, we are able to light up different functionality for those users later on in the runtime experience. And I'll talk a little bit more about that in a sec. Okay, so these are different layers and how we've thought about the provisioning system. And some of this actually we didn't have last time we talked about it. We actually added to it over time. There's a pre-provisioning step. So we have the ability to pre-create tenants in advance of them signing up. We do that at off-peak times for every network. And we create them in direct proportion to how many of each kind of tenant we get in production on a daily basis. So we like pre-creating them to make the experience faster. The provisioning, the core provisioning step, actually does one of two things. It'll either rename and assign an existing pre-created tenant to you as the new customer, or if there are no pre-created tenants, it'll go ahead and create one from scratch. It can do either one. It can deal with either situation. And when it's done, it'll signal to the Office 365 user experience that we're done by publishing a set of links that will let you navigate from that Office 365-wide user experience into SharePoint. And actually, there's also those links are also manifest themselves when you're in Exchange or in one of the other services. There's linking, connecting all of the services together. Then we get into a step that we call post-provisioning. And post-provisioning, really think of it as this is a set of asynchronous provisioning actions that can happen that do not block the usage of the tenancy. So you're a customer, you're ready to go. You can actually start navigating to SharePoint, creating documents, testing things out, while some steps actually complete in the background. And some of these additional configuration steps happen for all tenants. For example, configuring workflow, configuring search. And some of them are scenario specific, like project. For Project Online, we actually do some specific setup only for that, for customers of Project Online, like creating a new project-specific site collection. And that happens after the core tenant is provisioned and operational and ready to go. And then there are runtime behaviors. And these are, the runtime behaviors are not provisioning per se, but provisioning ensures that the right licensing information is available in SharePoint so that at runtime we can light up the right features. So for example, in Tenant Admin, if you are a Project Online customer, you will see Project Online management options. But if you're not, those will be appropriately hidden because they're not relevant to you. Provisioning owns making sure that information makes it all the way into SharePoint. So a few things that I wanted to show, some screenshots. This is essentially a provisioning VM running. Just wanted to show it. It's active. It has running a specific version of the service fabric. And one thing to point out in terms of versioning is that our components, while we're trying to always get all of our components to run the latest version of the service fabric, we stage the upgrade. So Grid Manager will upgrade before the provisioning components. They need to be able to work in that state for an unspecified amount of time, because it won't all happen at the same time. There can be a lag time between the update of different components. This is a pre-provisioned job. As I mentioned earlier, it drives the creation of tenants in off-peak times. It runs on an individual network basis, and it has goals set per language. So it creates tenants in all the different languages that are served by that particular network. And we usually base it on the proportion of actual tenants that come in the different languages. It also can create different tenants by version now that we support 2 versions sort of side by side. Deploy site job. This is yet another job. The deploy site job is a critical one. It actually creates actual site collections. And there's several scenarios. One of them is pre-creating a tenant. It runs a lot of the pre-create process runs in turn a bunch of these deploy site jobs to create your default site collection, your my site host, your tenant admin site collection, etc. It can also run in other scenarios. It could be fixing up a tenant that was broken. It could be creating a tenant from scratch as well. So many scenarios actually trigger deploy site jobs. This is the reassign site job, another really key job. It's part of taking the reassigning of an existing pre-created tenant to an actual customer. And one of the key operations that it performs is rename the URL. We assign those pre-created tenants temporary URLs. They need to get renamed once they get reassigned. And that's what you see in the data step in that command prompt. It's changing the site collection, whose site collection ID is blurred, into a new URL that I've also blurred out. But those are the key parameters. And finally, these are the properties of a tenant from Grid Manager that we sort of dumping out the top level properties for the tenant. It's a test tenant, so I can show you the name. A couple things to point out. It is running the SharePoint 2013 experience. You can see that by the required version property, 15 point. That tells us that it has the 15 or 2013 experience. Quota. The quota is another key property that provisioning calculates. If you buy new licenses, you're entitled to a certain amount of quota per user or per license. So we add that to your pool consistently. It's not a synthetic tenant. If you look at a property called isSynthetic, it's false. We actually run actual synthetic tenants to verify the integrity of the pipeline and to actually be able to run availability tests on them. And finally, if you look at the very last line, it shows you what licenses it has. We've changed the naming a little bit, but SPO Enterprise indicates that this is an enterprise tenant, obviously. SPO WAC indicates that the Office web applications are available, and SPO Project indicates that this is a project online customer. This information is available both in Grid Manager in the brain so that other jobs that take action on this tenant are aware of what capabilities the tenant has. So the jobs and any work that is done can check, is this a project tenant? If so, take action. And this data also makes it all the way into SharePoint site subscriptions so that you can actually light up functionality within the SharePoint runtime itself. Last thing I'm going to touch on, and I'm happy to talk way more about this topic afterwards. I'm going to try to move a little bit faster. So what is the role of provisioning in terms of tenant upgrade itself? So a couple of things I'll say about that. This first topic is how does the process work of supporting tenants in 2010 and 2013 side by side? Well, when a farm gets upgraded to 2013 bits, that's all done behind the scenes. The tenants on that farm are still in 2010 compatibility mode. So for all intents and purposes, all those tenants are still running the 2010 experience. They're still 2010 tenants in every sense of the word. The version and UX for new tenants being routed into that farm also by default is 2010. Effectively, in terms of our capacity, this is still considered part of our 2010 capacity. We didn't suddenly lose a farm that we can route tenants into. So nothing changes, only the underlying bits. Provisioning, though, at this point, provisioning is able to do both. If a tenant comes in tagged as 2013, it will give you the 2013 topology. So if it's a small business tenant that's 2013, instead of just getting one site collection, you'll get my site host, you'll get a separate public website, you'll get actually the full 2013 experience. Eventually, we'll start opening these farms, as I showed earlier, as I alluded to earlier in the network map slide. We can start opening these farms at any time now to handle 2013 tenants, but we'll do it, and we'll need to do it by the time that we hit general availability, when we expect most tenants, or very quickly, we'll go from mostly everyone provisioning in the 2010 experience to mostly everyone being the 2013 experience. So, this is an interesting transition, and it's all handled, made possible through the fact that provisioning can handle both versions, and of course, the backward compatibility features in SharePoint itself. Yes, got a question?
Yeah, will the customer, the client, hosted there have the option of upgrading from 2010 to 2013, what they already have there with content and everything? Is that what you recommend?
So I'm going to cover that in a second. So let me cover my last slide, and I'll talk to you about that. So as of the previous slide, a farm got upgraded to 2013 bits, but everyone running in that farm, all the existing tenants, are still 2010 tenants. How do those tenants become 2013 tenants? How do they get upgraded to a new experience? Well, we take advantage of the idempotency of provisioning. And the first thing we do, this won't start happening to general availability in general, but once we upgrade a farm, we can report up to an Office 365-wide orchestration process that, hey, all the tenants in this farm A, let's call it, they're ready. They're ready to be upgraded to the 15 experience in theory, or the 2013 experience, because the bits are already there. So this orchestration process will then check with all the other services. So if this is also an Exchange tenant, we need Exchange to also be ready to upgrade this particular tenant. When all the services are ready to upgrade this tenant A, they will then, the Office 365 suite-wide orchestration engine will go ahead and schedule, there will be a process to schedule the upgrade for the tenant. The tenant will be notified that, hey, you're scheduled to be upgraded to the new 2013 experience as of this date. This is when it will happen, and then it will actually trigger the execution of that upgrade. The way that upgrade works on the SharePoint side is that we simply use provisioning. We go ahead and we bump the version from 14 to 15, and then we say provision again. So provisioning will run, and if you were a small business tenant, for example, we run provisioning. We notice, hey, you don't have your my site host. Where is it? Well, we'll give it to you. We'll provision it at that point from scratch. You don't have a separate public website. We do it at that point, again, from scratch. So we create, essentially, provisioning's idempotency is used to fill in the gaps between the 2010 experience and the 2013 experience. And at that point, we say we're done. Once all of the services exchange, link, everyone says that they're done for any given tenant, the orchestration engine at the Office 365 level can actually confirm to the user, to the customer, hey, you're done upgrading. Now, there's a separate step for SharePoint, and I'm happy to chat with you guys about this afterwards. There's a separate step for existing site collections. We don't touch those. We leave those in 2010 compatibility mode, because those are we leave it up to the customer to opt in for each individual existing site collection. But at this point, that is unlocked. That process is unlocked. You can go click the button at any time and upgrade your individual pre-existing site collections to the 2013 experience.
I'm sorry, I didn't want to be interrupting you with that, but my question was not answered. Assume that there's no in-place upgrade for 2013 from 2010. How do you get the bits in that farm where you already have established clients?
So Duran is actually going to cover that right now, and I'm going to turn it over to him. Yeah. So hopefully now we will really answer your question.
Yeah, I'm going to run through this last topic really quick. So the question was, there's no in-place upgrade. How do we do the 2010 UI and 2013 upgrade? So I'm going to talk real quickly about how do we do upgrade in high availability fashion. First and foremost, when we designed this, we knew that there should be zero impact to customers when we upgrade the farms. It doesn't matter if we do a build-to-build or version to version. We have to upgrade both the service fabric, which is all the muscles, all the jobs, all the service fabric as we call it, and core SharePoint products where the user has no impact. When I say no impact, that means that we can guarantee that within a predefined window, which I think is around half an hour, so I don't remember the actual time, in which you get a read-only experience, we can guarantee either an upgrade or a rollback of a failed upgrade, and I'll explain what a failed upgrade is in a second. But you will get back your read-write capabilities at the end of the window. It's not like we try for the entire window, and if we fail, then we slip and we say, I'm sorry. No, we can guarantee a window that all the retries will happen inside that window. And the way we do that is, first we upgrade Grid Manager. So Grid Manager always gets the newer bits. If you can remember earlier in one of the design principles, I said that Grid Manager is version specific. It will always have all the jobs for all the available versions. So if it has a 2010 and a 2013 farms, it will have a deploy VM for 2010 and the deploy VM for 2013, and it will know which script to use against which farm. Then we upgrade the directory and all the service fabric farms. We upgrade the federated services farm. We upgrade the content farm. And at last, we upgrade the telemetry farms. We do that in a method we call a swing upgrade. Swing upgrade basically means we have a federated farm, a content farm, and the load balancer. First, what we do is we deploy a new federated services farm. It's the new build. It's the new binary. Think of it as 2010 on the left-hand side, 2013 on the right-hand side, or without SP1 and with SP1, etc. We start moving the services from one farm to another. And we put those services in a read-only state. Some farms we use a DB attach, like for taxonomy, and some services we use a backup restore, like for search. The end goal is that the old content farm is now consuming services from the new services farm. The users, at most, got read-only experience for some of the services. If it was search, it might have not been refreshed for a while. If it's taxonomy, it might be in a read-only state for a few minutes. But the content, their content databases, had read-write capabilities throughout this progress. So this is one of the reasons we've decoupled content and federated services in this design, allow us to upgrade a big portion of the stamp without affecting the users. The users had read-write capabilities on their content throughout this entire service transition. Now we do a similar thing with the content farm. After we release the service back to Grid Manager, we deploy a new content farm. Again, new binaries, maybe in 2013, might be a service pack, etc. We start going database by database. We never go all the database at once. Only tenants that are on that database are set. First of all, we copy the database. We put the database in read-only, and then we copy just the diff. So you will be in read-only for that database for a period of a few minutes, at most. We've done the majority of the bulk copy in the minutes before the actual read-only experience. We stagger database by database. So we never put everybody in read-only for the duration of the upgrade of the entire farm. It's only that window where your content database is. When that one is being moved over to the new farm, this is when you will be in read-only. Grid Manager is using the load balancer to keep tracks of which URLs are served out of the old farm and which URLs have been upgraded, or tenants have been upgraded and are served off the new farm. It will switch the traffic at real time. Again, this may happen over the course of a few hours, but the actual window in which each user will be under read-only shouldn't be more, and I don't remember the actual time, but it's around half an hour is the guarantee that we have. We always broadcast in advance, and Ben will talk about it. But again, if we fail to move your database across because there was some failure on our part, we will keep you on the old farm. And we have ability to run like that for days, where we troubleshoot those problems at the back end, but everybody still has read-write capabilities. Some on the old farm, some on the new farm, until we push everybody to the new farm and we decommission the old farm. So for your question, when the old farm was 2010 and the new farm is 2013, we upgraded everybody but we kept them on the 2010 experience until all the service fabric aligned, all the users are ready, everything behind the scene is ready, and then you'll have the ability to opt in, change, and upgrade yourself. Diverting traffic means that once we've finished, Grid Manager looks at his bookkeeping log, sees that all the URLs are now being served out of the new farm, and we can decommission those old farm. And that's something Grid Manager does in the backend. We're right on time, but Roberto and I are going to stay here for as long as you need and ask as many questions as you need, and we'll answer them. We ran really close to time, but we're going to stay. Thank you very much.
Thanks.